Welcome to the demonstration video of the GrazeScape Decision Support tool as part of the Grassland 2.0 project. This is going to be for version 1.0. So GrazeScape is a farm-based decision support tool. It allows a user to create a farm operation and draw out field boundaries and play around with some scenarios that could occur on that farm in terms of different management options. And then we can run some models under the hood and estimate some outcomes associated with those scenarios. It's meant to really walk a balance between being quick and easy and simple to use, and also being accurate and robust in terms of its estimates of these different outcomes, whether they're related to yield or soils or nutrients or runoff. We're trying to give a broad suite of the different outcomes that could happen under different management practices and land use changes. So I will give a demonstration. We'll walk through a farm setup and get you on your way. So the website that you need to go to is scapetools.grasslandag.org. And if you click on this for the first time, you'll notice that you'll have to log in with a username and password. Feel free to go ahead and set up your own user account. It's free to do, and it just requires an email address. So once you're signed in, you'll see a landing page similar to this, where you can choose between our two apps, GrazeScape and SmartScape. And there's some additional resources that you can click on that we're kind of adding to every day. So first, I am going to click on GrazeScape, and that launches us into our app. And just to give you a little bit of an orientation first, we've got our map window that is kind of the majority of the screen. And this is what we're going to use for interacting with the farm that we create and the fields. And there'll be different menus that pop up over that screen. And then on the left, we have a panel that's more of our text menus, and that will kind of shift as we go through the different steps in the scenario generation process. So the mapping part should be fairly familiar. It's similar to Google or Bing Maps. You can kind of zoom in and out with your scroll wheel as part of your mouse. And the first thing that we need to do here is choose our region. And the different regions that we have displayed here are associated with our learning hubs as part of the Grassland 2.0 project. And I'm going to go ahead for this demonstration, click on the Ridge and Valley Learning Hub. So now we have some farms that I have previously created showing up in these blue dots. And if you are a new user, you're not going to see any of those blue dots. It'll be a blank landscape. So for this demo, I'll create a new farm. And so I'll go over on the left here and click on Create New Farm. And you'll see a new menu pop up to give that farm a name. So I'll just call this Test and give it the date today. And I'll just put my name in for the owner, and I'll place it manually on the landscape. And I'm going to zoom in a little bit here with my scroll wheel and just kind of find a random spot on the landscape. So we're going to go with this spot right here. And then once you're done setting that farm location, it has created your farm in our database. And the next question is, let's get into a scenario, and what is the name of that next scenario? And what we like to have users think about with the first one is, what are the current conditions or the baseline for this farm, so that we can use that to compare with other scenarios. So for this demonstration, I'm just going to assume that this is a farm that has a few fields of corn and soybeans. So I'll just call this my corn and beans scenario. And then you can give it a little bit more of a description. We'll just have conventional spring tillage as an option. And then we'll go ahead and create our first scenario. And we do have some text to kind of guide you through the process. And I'll just kind of be annotating as I go here in a similar way. So now we're in our farm. You can see over here on the left and the corn and beans scenario. And now we've got this new menu of options, and we're going to kind of go from top to bottom. And the next essential piece is to draw out some field boundaries. So I'll click on Add Delete Fields and then place a field. And you'll also notice a couple other options for uploading field boundaries if you're a GIS user. But I will go ahead and draw these manually. And what I'm going to do is just draw 2 fields, and I'll double click to close that polygon that I just drew. And after you double click to close it, you can then give it a field name. I'll just call it field 1. And then the next piece of information right away that we need is what is the cropping system. And we don't have all of the different flavors under the sun here. We just have a wide variety of what could be available. So we've got pasture and a couple of different management options associated with pasture. A dry lot is an option, continuous corn or a cash grain or corn, grain, soybean rotation, and then 2 different dairy rotations. We've got a 5-year corn grain, corn silage, and 3 years of alfalfa, which is pretty standard. And then a second dairy rotation that's corn silage, soybean, and oats, just as a little bit of variety. And so for this scenario, this baseline, we are going to just call this a cash grain corn soybean field. And once I hit add field, you'll see it displayed here on the map. And again, I'll just add another field of corn and beans just so we have 2 to compare next to each other. And I'll call this field 2 and call that cash grain as well. And no, you don't have to have the same type of field. You can mix them up. Just for this demonstration, we're going to have 2 corn and bean fields. So now that we've got our field boundaries set and the cropping system set on each of these 2 fields, you could just skip right to run models and get the outcomes associated with this. We do have a bunch of default options that we provide kind of under the hood, and they're based on kind of reasonable approximations of what you might find across Wisconsin. But I'm going to open up the field attributes table and just show you around a little bit on what you can customize if you have more information for these 2 fields. And I'm not going to walk through all of these right now, but we have just some basics: the field name, the area in acres, some soil test information, and then a bunch of options related to management. So I'm going to hold this as is for now. Again, I'll walk you through this a little bit later on. But let's close this out for now. And I'm going to go ahead and just run the models. And what it's doing behind the hood is it's retrieving all of this spatial information from publicly available data sets like Surgo for soils and different digital elevation models. So you don't have to specify some of these things that are publicly available related to soils, for instance. And it's just automatically entered into the system. And so now you can see that the spinning wheel has finished, which indicates that the simulations are complete. And you see this field summary as kind of the first button that that is visualized, or the first table that's visualized. And we have each of the different crop rotations shown. Both fields, again, are corn and beans. And so it breaks it out into each year and then gives some information about the nutrients that are assumed to be applied to those fields and a little bit about the management. But I'm going to skip over that for now and just get right into the results, kind of going from top to bottom. So first is going to be the yield estimates. And these are based on a statistical model related to soil properties. And this kind of gives you a general indication of the yield you would expect for corn grain and for soybean. And so we can look at those for each of the two fields. And you can kind of hover over these bar charts to get more precise information. And you can also collapse it down into just an average for the entire farm. The first unit that you see here for yield is called total dry matter yield, which may sound strange for a corn and bean rotation. You might just be used to seeing it in terms of bushels per acre. But this dry matter yield is just a unit that we can compare across all different types of systems. So that is going to be our yield model. And I'll go down to our next one for soil loss. And so for the next three, actually, this is coming from SNAP Plus. And it's a statistical model, actually, of SNAP Plus that we have underneath the hood. And what we did was essentially ran SNAP Plus tens of millions of times. And what we're doing is we're drawing from that library of tens of millions of simulations and kind of taking the one that is the closest one to the field that you have drawn out in the app. So it's going to agree really closely with what you would find just using SNAP Plus on your own, except this, we hope, is a much quicker way to do it. So again, we are broken out into the two different fields that we drew, or we can collapse it down into a farm average. And we're seeing under these conditions, a corn bean rotation with spring tillage, soil loss upwards of 5 tons per acre per year. And then soil condition index is something that you may be familiar with. It ranges from -2 to 2, but gives an indication of a rough indication of soil health, the higher the number it is. And then I'll just go down through the next one here, nutrients. Of course, this is something, if you're familiar with SNAP Plus, that's kind of the main reason you use SNAP Plus, is to get an estimate of phosphorus runoff. And so we see a little bit of variety here on the two fields. And then nitrogen is estimated based on a pretty simple mass balance model, looking at all the inputs and outputs of nitrogen from the system and estimating the total nitrogen loss to water. And then we also have individually broken out the potential nitrate leaching. And for these fields in particular, I'm guessing what's happening is we're seeing quite a bit of erosion. And so a lot of nitrogen is associated with that erosion. And most of it is being lost due to runoff, and there's just not much available for nitrate leaching, and that's why it's down close to 0. So then we have the last piece that is related to SNAP Plus, which is just water runoff itself. And this is shown in terms of different size rain events. It's using the curve number method, which can come out of SNAP Plus. It's usually not displayed from a SNAP Plus output, but it's something that we can take advantage of here. Certainly, and there's a lot of people interested in reducing runoff and reducing flooding. So we can look at what practices can adjust that amount of runoff. So for a 5-inch rain event, we are getting about a little over 3 inches of runoff in this system. The next one is a statistical model related to the level of pesticides that are typically applied to a corn and beans rotation, and it gives you an index kind of related to the toxicity of pollinators, or honeybees in this case. I'm going to skip over the rest of these for now, and they'll be much easier to look at in comparison with another scenario. So I'm going to go ahead and close out of this model results window by going up here and clicking on the X. And we're going to go ahead and create a new scenario. And that's really, again, the power of this tool is to look at side by side different scenarios and compare them. So I'm going to click create new scenario. A new window pops up, and we have two different ways of creating a new scenario. The first is to duplicate an existing one. And that's one that we really would recommend most users using because it will copy over the field boundaries. So let's go ahead and click on duplicate. We only have one scenario available to duplicate, so we're going to go ahead and click on that. And we'll give our new scenario a name. And what I'm going to do with this new scenario is look at a managed grazing system. And I'll give it maybe just a little bit more information. We'll call it a 1-day rotation. And I'll create the new scenario. And what happened is it automatically just copied over those two fields, and it didn't change any of the options. So what we're going to need to do now is go into the edit field attribute table, and we will change the cash grain system to a pasture system. And you'll notice a few of the options are now grayed out. Cover crops and tillage don't apply to pastures. And I'm going to just go and change a few of these different attributes. I'm going to go and turn that into a medium yielding grass species variety. And then the rotational frequency I mentioned when I named it, we're doing this once a day. And again, I'll go back through this table piece by piece if you're interested in sticking around later in the video. So close that out, and we're going to go ahead and run the models again. And again, we're running through all those same models under the hood, taking in the information from those soils. And now we're just running a different system and pushing those through the models. And we have already saved the information from the baseline scenario, and it will automatically populate these different bar charts. So we'll go back up to yield, and I'm just going to collapse this into the whole farm scale. And it turns out on this field, when we're comparing dry matter yield, and again, that might be not the way you want to think about corn and beans, but if we're just harvesting the grain from our corn beans rotation and converting that to dry matter yield, it would actually be a little bit lower than the total dry matter yield we would expect from a well-managed grazing system. You can now see grass yield is a new unit. So that's, again, the same value as you see above, the tons of dry matter per acre per year. And then we still have our bushels per acre per year if you need that for reference from the corn and bean system. The next one, again, is erosion. And now we can see a pretty dramatic change. Again, our new scenario here is on the left, our managed grazing scenario. And at the farm scale, we have basically brought soil loss down to near zero. And we were up close to 5 previously with corn and beans. And our soil conditioning index is also much higher in that well-managed grazing system. For nutrients, it's going to be a similar story. Phosphorus is obviously intimately connected to erosion and soil loss. So we would expect there to be pretty low values for phosphorus runoff at around a little less than 0.3 pounds per acre per year, when again, that corn and beans was up above 6. And a similar story for nitrogen. We're expecting more to be lost to water in that corn and beans. And there's just, again, so much being lost from erosion that we're actually not seeing much leach according to this simple mass balance model for nitrogen. Then for runoff, we are seeing, again, a pretty dramatic difference across these different size rain events. And we can, again, focus on maybe the 5-inch rain event. We basically cut the amount of runoff for that 5-inch rain event, cut it in half from over 3 inches down to about 1.5 inches. So we're talking about substantial differences in these two different management options. Insecticide, again, we're assuming that our well-managed grazing system is not using pesticides and herbicides, and so you would expect a kind of lower toxicity index as it relates to pollinators. Production costs is something I'm going to skip over for now, and I'll go back to once we get back to the main menu. But I do want to show how we compare these scenarios to one another in a little bit more of a integrated way. So what this does is it uses a spider diagram, and it will take the base scenario, and then you can choose which of these variables you want to highlight together in the same chart. And so I'm going to pick just a few of these. We're going to do the overall dry matter yield, and we'll look at erosion and phosphorus, and then maybe runoff from a 5-inch storm. And you can kind of play around with the size of this window. We are still kind of fine-tuning some of the data visualization, but you can see the different axes of this spider diagram is showing you the different variables that you selected. And this is all kind of relative to the baseline, which is set at a value of 1. So the top axis is our rotational yield, and so we're seeing slightly higher in our managed grazing system, as I showed in the bar chart. And then all of these other attributes are actually lower than the baseline, and so those are closer to the center of the spider diagram. This is a good opportunity to mention we are always interested in feedback on these apps and different ways to visualize it in helpful ways. Let's see, one other thing I'll show is just a way to download these charts. You can click on download the summary report, and it just puts all those charts into an easy to read PDF. Or if you're a little bit more into the data, you can actually download it all as a comma-separated value file. So those are just two options to bring or save your information in a different format that you're more familiar with. Okay, I am going to go back to the main menu at this point and just show you a few other features of GrazeScape. And what we're going to do first is, since we're in the managed grazing scenario, one piece of feedback that we've gotten from users over the past few years of development is it sure would be nice to draw out some infrastructure and see how much distance it is to put a fence in, for instance. So I'm going to just demonstrate that real quick. So click on Add Delete Infrastructure and Place Infrastructure. And for this first one, I'm just going to draw out a big external fence boundary. And then again, we're going to double click and we'll label this infrastructure. This will be our kind of our exterior fence. And this is where we can choose from the different infrastructure types. Right now, what we have in is a water line or a lane line or a fencing line. And if you click on one of those, it'll then ask you for a little bit more specificity, what kind of material you want to use. So for this one, we're going to say it's high tensile electric 2-strand fencing. And what that does is we have a default cost per foot of that fence. So you can go all the way to an estimate of cost. So we have infrastructure added, and now that's highlighted here in yellow. And we can also see that in our infrastructure attribute table. And we've got the length associated with that fencing here at a little over 5,000 feet. And this estimated unit cost is from an NRCS handbook. You can feel free to edit it and it will adjust the total cost estimate. And so the same process can be used for the other types of infrastructure, the water line, the lane line. And so feel free to add whatever you may need for a transition from cropping systems to pasture systems. I'm going to click out of that table and go into edit production costs next. So this is something that we put in a while ago and have not really emphasized its integration with the rest of the tool, just because a lot of these costs just fluctuate so much. And these were set a few years ago and would likely need to be adjusted to get more accurate to today's numbers. But certainly encourage people that want to go down that road, they can, and they just need to make sure that these numbers are updated. But if you are happy with some of these selections, you can use it as a way to compare the production costs of each of your scenarios. So let me go back to the results. So I'll click View Results. And when I go to production costs, we're going to see that again at the field scale, or we can see it at the farm scale. And we can look at it in terms of cost per acre, total cost for the whole farm, or cost per ton of dry matter produced. And so if we were doing a little bit more of an apples to apples comparison, maybe looking at a dairy forage system, cost per ton of dry matter would make a lot more sense. But since we're looking at a corn and beans system compared to managed grazing, that's a little bit harder to do a direct comparison. But the main message here is that a lot of these systems are going to be higher in terms of production cost compared to the managed grazing system. We have much lower inputs. That cost just goes down substantially when you're not having to put on nutrients and do different passes with heavy machinery. So that's kind of where this production cost estimate is coming from. If you wanted to do more of a detailed economic analysis, I would really encourage you to check out our compass tools that you can look at back on our home page of the grasslandag.org website. That'll give you a little bit more fine-grained detail on some of these production cost comparisons. Let's see, I am going to show you one last thing. I'm going to actually show you how I go back to a previous scenario. So we've got these back buttons that we can click on. And I'm going to go re-enter the corn and beans scenario. So I select it and then I hit Edit Selected Scenario. So now I'm back. You can tell cash grain is on both of these fields. And I'm going to go ahead and enter into the results again. So at this point, we do have to rerun a few things under the hood before we can view the results. This is something that we're kind of actively working on as a development team, is storing this information in a little easier way so that you don't have to rerun a scenario if you go back to it. So stay tuned for that. But the last thing I want to show you is the results that we can map. And this also gives you a little bit of a glimpse into how the model is run under the hood. So we're in our model results window, and I clicked on mapped results, and I'm going to click on phosphorus loss first. And you see a colored representation of phosphorus loss for these two fields. And the colors are going to be consistent with this color bar up in the upper right-hand corner. And so the first thing you notice is that, oh, there's a lot of variability in these two fields. It goes from, looks like down close to 1 or 2 pounds per acre per year, all the way up to 12 or more. And what's happening here is you're seeing differences in slope, most likely in these fields. And that gives you an idea that the models under the hood, they aren't just simulating the field all at once. It's simulating each individual pixel that you see on this map. And then we're averaging the results when presenting the information in the bar chart. But that bar chart kind of leaves out all this detail under the hood. And so this can be used, I would say, with some caveats. It is limited by the accuracy of the underlying data. The slope, we have a pretty good idea. It's relatively accurate. But the soil types are still a little bit limited in terms of their accuracy. Again, they're from the USDA Surgo database, and soil surveys aren't always regularly updated across the state. So I would caution a little bit with interpreting this in kind of a precision agriculture type of way. But the initial feedback that we've gotten from people is that this is consistent with what they see on their field. They notice some of the higher sloped areas where they would expect more loss of soil and phosphorus. And that lines up with some of these maps that we create. So we're putting it into the app, again, with some of those limitations and caveats, with the hope that they are useful for users in kind of looking at the variability within each of their field, and maybe even making management decisions that are different depending on what part of the field you're looking at. So I am going to conclude our demonstration at this point, and just recognize that there's a lot more that this app can do, and we're always happy to hear your feedback. So thanks again, and we hope to see you out there.